Hi, class. It's Professor Rourke again. So 3.2 was a particularly challenging section. It is every time we take this class because it not only introduces standard deviation, but then it also starts introducing the empirical rule. So one quick note, empirical rule will be given to you on your formula sheet that you can use for the quizzes and for the tests. So I'm going to be sending that out to you this week so you can have that for any of the quizzes or tests that you want to take, since actually like the first test isn't too far away. So you just want to kind of keep that in mind, that will be given to you. But it is also, on the other hand, good to like know what it is in general and be able to understand what the question's asking without having to look specifically to even know where the formula is, right? So 3.2 number 12 is a question from homework that is a perfect example of the empirical rule and what we want to do to solve it. So I wanted to walk you through what you want to do to solve these problems and how you know when you're supposed to do this. So 3.2 number 12 says the weight of an organ in adult males has a bell-shaped distribution, okay, with a mean of 320, okay, and a standard deviation of 15 grams. Okay, so then from here, let's see, bell-shaped distribution. It says use the empirical rule to determine the following. So for this particular problem, first of all, empirical rule, what is the empirical rule? Again, it is going to be listed on your formula sheet, but it is also good to sort of know what it is without having to, again, look to see that, because otherwise you won't even really kind of know where to look, right? So anytime you see a problem that tells you it's normally distributed or a bell-shaped distribution, or specifically empirical rule, that's telling you that this is a normal curve. And unfortunately, I am going to want you to sketch this out. This is a particular problem that I like to ask on the test for the written portion, because it's one that is fairly straightforward as long as you kind of just like follow along with what I'm telling you to do. It doesn't get too crazy. So when we are given a bell-shaped distribution or a normal curve, we always want to start by labeling the center as the mean, which here is given to us as 320. And then it says the standard deviation is 15. So hopefully from your interactive assignments, or maybe you checked the notes, you sort of know that this means that we could draw a 1 standard deviation, 2 standard deviations, 3 standard deviations to the right, and then the same idea, but to the left, where we would subtract the standard deviation. Okay, so what the empirical rule says is that 68% of the data is between 1 standard deviation below and 1 above. Then 95% of the data, again, these numbers are just, I know they feel really random, but they're going to stay the same every time. 95% is between 2 standard deviations below and 2 above. And then 99.7 is between 3 standard deviations below and 3 standard deviations above. Also, it's so helpful to know that 100% of the data is underneath of the curve. Makes sense, right? And then this is also symmetric. So there's 50% to the right of the mean, and there's 50% to the left of the mean. Okay, so all of those pieces together come together to help us answer these questions, but I promise you it's very straightforward once you kind of get the hang of it. So I have the 320 labeled in the middle, and now I need to take that 15, which is a standard deviation, and add that to 320 to figure out what I'm going to be labeling those numbers as. And you do, unfortunately, need to do this every time because it's key, really. Without drawing this curve and without labeling these numbers, you're not really going to be able to solve this. So 320 plus 15 is 335. 335 plus 15 is 50. And then 350 plus 15 would give us 365. Okay, so now I have the mean in the middle of my normal curve. I have 335, 350, and 365. And now I do the same thing to the left. So 320 take away 15 would be 305. That would be 1 standard deviation below. Take away 15 again. So that would be 290. And then 290 take away 15 again would be 275. Okay, so that's good. I have all my numbers, and now I can answer the questions because it's going to make my life a lot easier. So this is what you want to do every time. Okay, I know on an online class, it's hard sometimes to know what to write down, but this is definitely one of them. Okay, so this first question says about 99.7% of organs will be between what weights? Okay, so that is asking us really to find 3 standard deviations below and 3 standard deviations above. And thankfully, we already have them all drawn out, right? So their 99.7 is from 275 to 365. Those are the numbers that we're looking for. Okay, so as long as you have them all labeled, then it's really much simpler to be able to identify what they're asking. Okay, the next part says, what percentage of organs weigh between 305 and 335? Also be careful because sometimes I misread these when I go fast. So which one's B, which one's C? What percentage of organs weigh between 305 and 335? Well, thankfully, we already have our numbers drawn and labeled there, and we can see that that is 68%. Okay, that is just the rule. Honestly, I know they're so random, 68, 95, 99.7, that's what they're there for. Okay, the next question says, what percentage of organs weigh less than 305 or more than 335? So see how they're kind of building on each other, but if we have less than 305, I'm going to use a red color just to kind of shade to the left, and then I'm also going to go ahead and shade to the right. Okay, so really this is saying they want all of the data that's not in between. Okay, so we already said that 68% of the data was in between. And again, remember that 100% of the data is all around this curve. So does it make sense for us to take 100%, take away 68%? 100% minus 68% would give us 32%. There is another way to do this, which I can show you in a second, where you like add up every little piece, and that works as well. So I will show that to you in a second after we answer part D. Part D says, what percentage of organs weighs between 275 and 350? Okay, so let's think about how we're going to solve this one. This one is one of the more complicated ones because 275 is 3 standard deviations below, right? Here we are, all the way on the end here. But 350 is 2 standard deviations above. So it's not a direct like 68, 95, or 99.7, right? Because we already, those are the rules that we know, and then we could find the other pieces, right? But it might take a little bit of time. And so that's why I have a formula sheet for you that I'm going to be sending out later today. Let me go ahead and pull it up so I can kind of reference what it's going to look like if my computer doesn't have a meltdown. Okay, good. It's doing okay. Okay, so the formula sheet, which again, you are allowed to use on the test and also any possible quizzes, you can use those as well. It's going to look just like this. So it says Math 135 for test 1. So really it's like the midterm essentially. Give me 1 second. Okay, here it is. And it says it's broken up. Chapter 2 didn't have too many formulas. Chapter 3 does have some more, right? They have the Z-score, they have the interquartile range, and they also have the formulas for fences. And then this is the empirical rule broken down into sections. Okay, so I know there's like 2 normal curves going on here. I have the one drawn and then the one that will be on the formula sheet. So if you take a look, this is what I was saying before was sometimes like another way to solve what we just did. We just took 100%, take away 68%. The other option though, is to look at these little pieces and add them up. Okay, so let me go ahead and write on this particular one so that you can get an idea of what I'm asking. So some students like to do this as well, where they just use this particular one with like a pencil and they write on it and then they erase it and then they write on it and then they erase it, which definitely works for some people as well. So back to our question, we had, again, remember we had like 320 in the middle and we had labeled it to the left and to the right. And that's what we're going to do here as well. So we have like 320, we label it to the left, label it to the right. Okay. So for the question that they asked before that I said there was another way to do it, instead of taking 100% minus 68% to figure out what was on these tails, right? We could have, in theory, just added up all the little pieces that we have labeled here. So 0.15 plus 2.35 plus 13.5 plus 13.5 plus 2.35 plus 0.15. Okay, you would still get 32% like we did before. It's just that it's a little bit more steps, right? A little bit more we have to add. But for a question like we have on part D here, where it's asking between two different values. It's saying between 275 and 350. So if you remember, I know I'm getting, I just being kind of lazy and to write this all down. 350 was 2 standard deviations to the right, and then 275 would be all the way over here. So what sometimes this is a good candidate one just to go ahead and add up. We want between 275, so you want 2.35, 3.5, 34%, 34%, and 13.5. If we want to go ahead and add up all of those pieces, that is actually going to probably be the quickest way for us to be able to answer this particular question, just because it's kind of tricky once you start going between different deviations, right? You also, in theory, there's so many ways to solve these. You could also have said, oh, okay, wait, you know what? I know that this only has a tiny bit, it's only 0.15% over here. And I know that this over on the right-hand side to the right of 350 would only be 2.5%. So really, in the only thing that's not in those would be 2.5% plus 0.15%. So 2.65% is not inside there. So 100% plus minus 2.65%. So I know there's if that sounds too complicated for you, don't even worry about it. It's just, I'm always amazed by these particular problems, the different ways that people think about it. I'm like, wow, yeah, I didn't even think about that. You could do this. It's kind of like a puzzle, right? But essentially the main idea is that we need to make sure that we have our normal curve drawn and all of the numbers labeled underneath of it in order to be able to solve any of these empirical rule problems. Otherwise, you're just going to be kind of grasping at straws, right? So I think that's part of the problem as well from 3.2 is that if you don't draw it out, sometimes it can get super tricky. So please keep me posted with any questions you have. I'm always more than happy to make a little recording and send them out. Also, don't forget to check the announcements. They're super important for all of the important information for our class. Okay, thanks so much, class. Have a great day and keep me posted. Thanks.